Okay, consider two bodies A and B of masses m1, m2 moving along the same straight line with velocity u1, u2 respectively. Now assume that u1 is greater than u2. The body suffers a head-on collision when they strike and continue to move along the same straight line with velocity v1 and v2 respectively. Assume the collision is elastic. Show that u1 plus v1 equals to u2 plus v2. That is the first question. Hence, find an expression for v1 and v2 in terms of other parameters. 3. Determine the expression of v1 and v2 when m1 equals to m2. Hence, if the particle is initially at rest, find the expression for v1 and v2 in 2 above. So to solve this question now, all I need to consider is, in that question, you need to show the direction of motion of these two bodies. Before collision, we have the body, two body A, and another body B, moving in the same direction, that is the same direction. So this will be MA, UA, MB, UB. All this happens before collision. And again, after collision, what do we have? We still have A and B still moves in the same direction. Final velocity v of A, v of B, MA and MB after collision. After collision, so what do we need here? We need to apply the principle of conservation of linear momentum. So what does the principle of conservation of linear momentum state? We have it that what? MA UA, total momentum before collision, plus MB UB equals to MA VA plus MB VB. But if you look at this question, we're told that we are having M1 and M2. So A here becomes 1, B becomes 2. So this law becomes M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. Now, what do we have here? This is the principle of conservation of linear momentum. This is plus. Now, how do we go from here? Bring all the initial together. That is, I'm bringing M1 with U1. Then Vm1 and V1 will come to this other side, become minus M1 V1 equals to, on this other part, our M2 V2 minus, then this will come over here, M2 U2. Now this is it. At this point, on the left hand side, M1 is common, so I'll bring out M1 common factor, open the bracket, then our U1 minus V1, close the bracket. That will be equals to, what is common here? M2, bring out M2, so here you have M2, then what is left? V2 minus U2. Call this equation 1. Now from the question above, we're told that what the collision between them is elastic. So if the collision is elastic, that is, kinetic energy is conserved. So we have to look at that okay, kinetic energy before collision, call that Ke1, must be equal to the kinetic energy after collision, which is K2. So before collision, kinetic energy 1 over 2 M1 U1 squared plus 1 over 2 M2 u2 squared equals to, this is before collision, after collision 1 over 2 m1 v1 squared plus 1 over 2 m2 v2 squared 1 over 2. So if you look through this, 2 is common all through, so multiply through by 2, multiply through by 2. If you multiply through by 2, 2 will multiply this, you'll be left with m1 u1 squared plus m2 u2 squared equals to m1 v1 squared plus m2 v2 squared. Now, same way as equation 1, bring all the m1 and v1 together. So here now we are going to have m1 u1 squared, then this coming over minus m1 v1 squared equals to m2 v2 squared, m2 v2 squared minus m2 u2 squared. Now let's go to the next page. The next page. So we are going to have m1 is common, so we have m1, then I have u1 squared minus v1 squared equals to m2. What is common there? M2 is common, then we are left with v2 squared minus u2 squared. Close the bracket. So now this, now we can still simplify this by saying this is same thing as m1 u1 minus v1, then we put square for this. That is, we are trying to bring in difference of 2 squared. Then you have m2, then here also will be v2 minus u2, then I'll put square here. Call this equation 2. So what do I need to do here? Divide equation 2 by equation 1. And what is equation 2? The last equation, m1 u1 minus v1 squared equals to m2 v2 minus u2 squared. And what is equation 1? We'll now divide it by equation 1. Equation 1 above is m1, which is u1 minus v1, then this also over m2, which will be v2 minus u2. Now, from difference of 2 square, note, in difference of 2 squared, if you have a minus b squared, it is same thing as what? A plus b and a minus b. A plus b, a minus b. So if we apply that idea here, let me pick another pen. If I apply that idea here now, I'm going to have m1, which, open a bracket, u1 minus v1, close the bracket. This is for the negative. Open another bracket, u1, then plus v1 close the bracket over m1 m1 u1 minus v1. Then on the other side we also have m2 v2 minus u2, and that will be v2 again minus u2, and the other side will be positive, over m2 v2 minus u2. So v2 minus u2 cancel v2 minus u2, u1 minus this cancel this, m1 cancel m1, then m2 cancel m2. I'm left with u1 plus v1 equals to v2 plus u2. Call that answer the Roman figure 1. So call this equation 3. Now in equation 3 now we've answered the first question, which is show that this is disproved. Then go to the next page. So from that last equation, the last equation there is u1 plus v1 equals to v2 plus u2. So I can make either u2 and v2 and v1 the subject of formula. That will give me another equation, which will be equation 4. So let's make v1 the subject. v1 now will now be equals to, if you make v1 the subject of formula, that will be v2 plus u2, then u1 is coming over minus u1. Call this equation 4. Then similarly make v2 the subject of formula. v2 again will be u1, which is what we have on the left hand side, plus v1, then u2 will come over minus u2. Call this equation 5. So for we to proceed to the second part of the question, I need to put the value of equation 4 and 5 into the principle of conservation of linear momentum. And what is the principle of conservation of linear momentum? m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. So this is the equation that we need now. So all I need here is to put 4 into this equation star. So if I do that, anywhere you see v1, we replace it with v2 plus u2 minus u1. So I have m1 u1 plus m2 u2 equals to m1, open a bracket for v1, v1 is v2 plus u2 minus u1, close the bracket, then what again do we have? Plus m2 v2. So open this bracket now, m1 u1 plus m2 u2 will give, open that, m1 v2 plus m1 u2 minus m1 u1 plus m2 v2. All I need to do now is to gather all the 1 1 1 1 1 together. The m1 u1 m2 u2 that has to do with u on one side. So if we do that, I'm going to have m1 u1 at first. There's another m1 u1 here, which is negative. Coming over here, it becomes plus m1 u1 again. Then There's another one plus M2 U2 M2 U2. There's still another one minus M1. That will be minus, because this is coming over, minus M1 U2, everything equals to the V that is left, which is M1 V2 plus M2 V2. So M1 V2, which is equals to M1 V2 plus M2 V2. Now come to this left hand side. This and this are same, so if you add it together, 2 M1 U1, then if you look at these two, something is common. They have common U2 U2, so only what is not the same is M2 and M1. So pull out the U2 plus U2, then inside here you have M2 minus M1, close the bracket, equals to, on this other side, what is common there? V2 is common. Pull out V2, then open the bracket. You are left with M1 plus M2. Now we'll proceed. Now we are asked to get an expression for V1 and V2 in terms of other parameters. So we have an expression for V2 only if we make V2 the subject of formula here by dividing both sides by M1 plus M2. That will make V2 the subject of formula. So what we had now left is divide both sides by M1 plus M2. You have V2 is going to be 2 M1 U1 plus U2, open a bracket, M2 minus M1, close the bracket. We are dividing this by M1 plus M2. This is your equation 4, which is you have gotten an expression for V2 in terms of other parameter. We have stylishly answered our Roman figure 2 now from here. From this part, we have answered Roman figure 2, which is the other part of the question. So this becomes equation 6. So similarly again, put equation, put 5 into the equation of conservation of linear momentum, which is star. So that gives what is equation M1 U1 plus M2 U2, M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. So once you have this, what are we putting now? We are putting the value of equation 5, which is V2. Anywhere we see V2 from equation 5, V2 is U1 plus V1 minus U2. So anywhere we see V2, we put that. So you are going to have M1 U1 plus M2 U2 equals to M1 V1 plus, now put in the value of M2 V2. This will now be U1 plus V1 minus U2. So open this bracket. You have M1 U1 plus M2 U2 equals to M1 V1 plus M2 U1 plus M2 V1 minus M2 U2. So bring all the u and u together. So I have m1 u1 plus m2 u2, what we have on the left hand side. Then you have m2 u1 here. I'll bring that to the other side. It becomes minus m2 u1. Then I have m2 u2. Negative coming over, it becomes plus m2 u2. Everything equals to the v. m1 v1, then plus m2 v1. Now come to this first equation. What can we put together? m2 can be added to m2, so that will give 2 m2 u2. Adding them together, then what are we left with? m1 u1 and minus m2 u2. So u1 and u1 is common here. Pull out u1 plus, pull out u1, u1, open a bracket, m1 minus m2, close the bracket. Then on this other side, something is common here also, which is v1. Pull out v1, v1, then open a bracket. You are left with m1 plus m2, close the bracket. Now all we are asked to do is to make v1 the subject of formula, that is to get an expression for v2 and v1 in terms of other parameters. So if I do that, that will lead me to the next equation, which shows that v1 is going to be 2m2 u2 plus u1 plus u1, open a bracket, m1 minus m2, then divided by m1 plus m2. Call this equation 7. Now we've answered question Roman figure 2 completely, so let's go to Roman figure 3. For Roman figure 3, okay, we are asked to, we're told that if m1 now equals to m2, that is in equation 6 and 7. Let's start with equation, the last equation, equation 7. Get an expression for v1. Anywhere you see m1, turn m1 to m2. So this becomes 2 m2 u2 plus u1, then m1 turn it to m2, m2 minus m2 all over m2 plus m2. So here now m2 minus m2 is 0, so this approach 0. Then you are left with v1 equals to 2 m2 u2 over 2 m2